In the next video, we're gonna practice fundamental identities. In this video. And those are as follows. And again, you guys need to remember those. The tangent t is sine divided by cosine. The secant is 1 over cosine. The cosecant is 1 over sine. And cotangent is 1 divided by tangent or cosine over sine. So it's inverted tangent, basically. And like we said before, these are basically your ratios of sine to cosine, so forth. So yes, and inverted sine and inverted cosine, and they will stay the same no matter what your circle is, if it's a unit circle or it has a different length of the radius. It only depends on the angle and not on the radius of the circle. All right, so let's put those identities to work. Here in this example, they're asking us use identities to evaluate trigonometric functions. And so they gave us the sine of 45 is square root of 2 over 2. The cosine of 45 is square root of 2 over 2 as well. And we need to evaluate the tangent. So we know that the tangent of 45 degrees is sine of 45 degrees divided by cosine. Well, what is sine? Sine, they told us that it's square root of 2 over 2 divided by the cosine, which is also square root of 2 over 2. So we have root of 2 over 2 multiplied by the reciprocal, and everything cancels out, and we are left with 1. Okay, so tangent of 45 degrees is 1. The next question is, we have a sine of 5 pi over 6 is 1/2, and the cosine of 5 pi over 6 is negative root of 3 over 2, and we need to evaluate the secant. So secant of 5 pi over 6 is 1 over cosine of 5 pi over 6. So it's 1 divided by cosine, and cosine is negative square root of 3 over 2. So we turn it into multiplication, and we can move the negative sign. Where's my pen? Here it is, found it. So I'm going to rationalize the denominator, and I'm going to get negative 2 roots of 3 over 3. And that's the answer for question B. So it becomes easy. You don't even have to look at the circle and think about what is the sign of your function. When you use those identities, everything becomes a matter of manipulation, some fraction divisions, basically. Okay, here you go. I want you to evaluate cosecant of 7 pi over 6. And I assume that you paused your video and already figured it out. So we are gonna continue. Knowing those identities is very important. So in this case, for example, if you knew, your reference angle, for example, for 5 pi over 6, you could have figured out this value even without using identities, right? Um, just by looking up on the chart like we did before. But what we're going to do in this class, other than evaluating trig functions of different angles, is also use identities to simplify trigonometric expressions. And the knowledge of the definition of those trig functions and the knowledge of trig identities is going to become crucial for that skill. Okay, so don't delay in learning those identities. All right, so let's go ahead and simplify that. I'm going to copy it in slightly bigger form. Secant of t divided by the tangent of t. So the first thing that I would recommend is basically to apply our identities. I'm going to rewrite it as secant of t, and I'd like to put my my function input in parentheses. I'm going to rewrite it in the expanded format because each one of these is going to be a fraction, right? We remember that the secant t is 1 over cosine t, and the tangent is sine t over cosine t. So let's apply our rules for multiplying fractions. And we're going to copy 1 over cosine t, turn division into multiplication, and flip the second fraction. And we're gonna cancel out the similar factors, so cosine t on the bottom and cosine t on the top. And I want to remind you that you can only cancel out over multiplication, not over addition or subtraction. So it works here. So we have 1 over sine t left, and that's our definition of a cosecant function. So that's our simplification. So secant t divided by tangent t is reduced to cosecant t. Now I want you to try this now. And you're gonna multiply tangent t by cosine t and see what you come up with. Again, pause here. And we're gonna continue in a sec.